by parts. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. In integration by parts, we will take UN, the derivative of the second function is visualized, and it is given as integral udv is equal to uv minus integral vdu. What are the steps involved? We have to identify the function u. There is a rule for it. The remaining function inside the integral is taken as dv along with dx. Differentiate u to get du, integrate dv to get v, and put it in the formula uv minus integral vdu. We are visualizing the integral as a function into derivative of the second function. Now today we are going to see the combination polynomial and trigonometric. Here we have to take u as the polynomial, because only polynomial function, when you differentiate, it will get reduced. Therefore integral x sin x, here polynomial is x or algebraic function is x, therefore u is equal to x, the remaining is dv. When you take x square cos x dx, here x square is the algebraic function, for u is equal to x square and dv as the remaining. Here x into secant square x is a algebraic function or a polynomial function, but that is to be taken as x, and dv as secant square x dx. Let us try some problems now. X into sin x dx. Very simple. U should be taken as x and dv as the remaining. Immediately find du and find v. That is integral sin x is minus cos x. Put it in the form u into v. Therefore minus x cos x minus integral v du, therefore minus cos x into dx. It will become minus x cos x plus integral cos x dx, therefore cos x dx is sin x, so you got the answer as minus x cos x plus sin x plus c. Now similarly you can do a problem on x square sin x also, where the integration by parts will be repeated 2 times. Now suppose you have x into cos square x dx, which is to be taken as u, polynomial function x, dv as cos square x, du is dx only. Now let us try to find the value of v. It is integral cos square. Already we have discussed, whenever you have cos square x, we have to use the formula cos 2x is equal to 2 cos square x minus 1. From this you get cos square x as 1 plus cos 2x by 2. Now do the integration now, half into 1 plus cos 2x dx. First integral is x, therefore you have to use the formula integral dx as x. Second integral will be cos 2x dx. We have to use the formula cos x dx is sin x. Therefore half into integral of x is, 1 is x plus integral of cos 2x is sin 2x upon 2. As the coefficient of x is other than 1, you have to divide by that. Okay, anyway. Therefore v is x by 2 plus sin 2x by 4. Put it in the form now, u into v, x into x by 2 plus sin 2x by 4 minus integral v du, x by 2 plus sin 2x by 4 into dx. Now let us continue. Let us expand the brackets now. X into x by 2 is x square by 2 plus x into sin 2x by 4 minus, on the right hand side there is a integral which can be split into 2, minus half into integral x dx minus 1 by 4 into sin 2x dx. Now what is the formula for the first one? It is x square by 2. Value for the second one is integral of sin x is minus cos x. Put it a formula now for minus half into x square by 2 first integral minus 1 by 4 into minus cos 2x by 2. Now this is the way that we are simply multiplying the constants. Now this x square by 2 and x square by 4 can be clubbed, and we will get the final answer as x square by 4 plus x sin 2x upon 4 plus 1 by 8 into cos 2x plus c. Here problem is very simple. There only the getting the value of v, you have to consider it as a separate problem, and we are integrating cos square x to get the value of v. Okay, now this is a problem of inverse trigonometric function actually, but you can do it by doing substitution, converting it into a problem where it contains algebraic function and trigonometry. Every problem, suppose if you have x into sin inverse x, x square into sin inverse, all the problem can be converted. Anyway, now let us take x is equal to secant theta. If it is secant inverse x, put x is equal to secant theta. If you have sin inverse x, put x is equal to sin theta. We are now converting this problem into another problem by means of substitution. Therefore find dx. Then what is theta? It is secant inverse x. We are ready now. For now, secant inverse x dx is, for secant inverse x I am putting theta, for dx I am putting secant theta tan theta into d theta. Now this problem can be visualized as a problem where we are having algebraic function and trigonometry. Take u as algebraic function, that is theta, dv as the trigonometric function, that is secant theta tan theta d theta. Immediately find du, it is d theta. Find v, integral of secant theta tan theta is secant theta. Put it in uv minus integral v du form, u into v theta secant theta minus integral v du secant theta into d theta. Let us continue. Now we are having a direct formula for integral secant, it is secant x tan, for we are directly substituting it. But now we are ready for resubstitution because the given problem was in terms of x. Now while we are doing the resubstitution, check out whether all can be resubstituted directly. Theta can be done, secant theta can be done, but tan theta we have to convert it in terms of secant so that we can do substitution. We are having a formula 1 plus tan square is secant square. Therefore tan square is secant square minus 1. Therefore tan theta is square root of secant square theta minus 1. Because 1 plus tan square is secant square is secant square minus 1, for tan is square root of secant square minus 1. Now you can do the resubstitution now. X into secant inverse x minus log of, for secant theta x, for square root of secant square theta minus 1, it is root x square minus 1. Let us go to a next question where we are having sin inverse by 1 minus x square whole power 3 by 2. Let us now try this by converting it into normal trigonometric function by doing substitution. Put x is equal to sin theta, dx is cos theta d theta, theta is sin inverse x. We are ready now. Now let us now do the substitution. Numerator sin inverse x will be replaced by theta. Denominator 1 minus x square whole power 3 by 2 will be replaced by 1 minus sin square whole power 3 by 2. Dx is cos theta d theta. What is 1 minus sin square? It is cos square. What is cos square whole power 3 by 2? It is cos cube. Therefore theta by cos cube into cos theta. Cos and cos can be cancelled. You will get theta by cos square theta, which is theta into secant square. Now you see it got reduced to a very simple one where it is having a lot of whole power 3 by 2s, inverse and all. It got reduced to theta into secant square theta d theta. Now we are visualizing this problem as a problem of algebra and trigonometry. Now put u is equal to theta, dv as secant square, du is d theta. What is the different integration of secant square? It is simply tan. Now put it inside the integral sign now. uv minus integral v du. For u is theta, v is tan theta minus integral v du tan theta d theta. What is the formula for tan? It is log secant. Okay. Now we have a substitution only for x is equal to sin theta. We have to convert everything in terms of sin. Therefore tan theta is sin by cos, secant theta is 1 by cos, but we are having a formula sin square plus cos square theta is 1. Therefore cos square theta is 1 minus sin square, where cos theta is root 1 minus sin square. Now we are ready for this substitution now. Theta is to be replaced by sin inverse x, sin theta wherever comes it should be replaced by x. Therefore x into sin inverse x by root 1 minus x square minus log of 1 upon root 1 minus x square plus c. Let us move on to the next question number 5, sin root x. Whenever in everywhere we are not sure about any substitution, try by taking whatever inside the square root as t square. For I take x is equal to t square, 2 dx will be 2t dt and root x is nothing but t. Now let us put it now. It will become sin root x, therefore sin t, dx therefore 2t dt. Now how to visualize it? 2 into integral t into sin t dt. Now we are visualizing this problem as a problem of algebra and trigonometry. Take u as t and dv as sin t dt, du as dt and v as integral sin t dt, which is minus cos t. Therefore 2 into integral t into sin t dt can be written as 2 into u into v, therefore t into minus cos t minus integral v du minus cos t into dt. Therefore we are getting this answer now. Therefore integral of minus cos t is minus into minus will become plus, therefore you will get plus sin t. Now we have to do the resubstitution. 2 into t should be replaced by root x. For very simple. Therefore root x into cos root x plus sin root x plus c. Here, even though this problem cannot be done directly, we are doing substitution. The substitution leads to a problem of integration by parts. Success is dependent on efforts. All the best.